First question that we have is from George in Connecticut. And he's asking the questions, would a transit or a laser level be more helpful in laying out footings in the basement? And Derek will answer that question.
Sure. So they're kind of, in a lot of ways, two different tools. So a laser level does similar things to a transit in that if you determine a particular height and you set the laser at that height, you can move around to different locations and find that same height, so you can make sure everything is level or true to that particular point or height that you're going for. And a transit will do the same kind of accomplish the same thing, but a transit will also help you locate distance from the center point, for instance, which is very helpful with domes. So here's a picture that Tanner put up of Dennis using a transit, and he's able to determine height, but then you can also tilt the transit and you can find certain distances to a point and make sure all your points are on that same plane as the transit. And the transit can be broken into 72-degree increments. So you can kind of find, here's the fifths of the dome. Every 72 degrees of it, does this point land where it's supposed to? So it does a little bit more, which makes it a little bit more useful, I think, anyway, for foundations. You know, if you're doing garage doors or you're doing different paneling or something, laser levels are great. They give you a nice visual line. You can set it up and walk away from it, and you don't need a second person to tell you where it's at, which is nice. But I think for foundations, the transit's still probably the better tool. At least that's my thoughts on it. So
I guess I would agree too, because that's what I'm used to using. You can rent transits from the rental places around. Laser levels, certainly they work for leveling things at the same plane in a room, but there's a place for them and there's a place for transit. And the transit works from that standpoint of tilting the transit up and down vertically along the plane, because it's always going to be, as long as the bubble's in place and you have it level, you are going to have a vertical line that you could draw, in a sense, with the transit. Whereas the laser level, now there's some very sophisticated laser levels doing the same thing. So that's going to have to be your decision on what you're comfortable with and what you're trying to do.
Right. Yeah, real quick on that, I guess. It is great for digging out your footing and stuff. You can get those ones that will beep, you know, when you're moving the story pole, and it will give you a little indicator of when you're at the right height. But I just feel the transit really is nice for getting that exact point on the corner for laying. And, you know, when you actually come time to lay out your footings themselves, we're not digging, but perfect. So our next question, and for those of you that ask the questions that are here and you want to jump in, or maybe we didn't answer the question you were asking, feel free to jump in. And, you know, we always like to kind of encourage a little bit of a conversation. We do have a good amount of questions to get through, but it's nice if anybody has a comment to make or other experiences to share, it's always appreciated. So our next question is from Hugh in Maple City. And he is asking, what is the cost and longevity and viability of this type of housing in cold climates? So that's from Hugh. If you want to grab that one, Dennis.
Yeah, the dome that we're in right now, it's our new dome, but our new dome is 15 years old. The original dome on the property here was built in 1975. We did some extensive remodeling in 1983, which is now 39 years old. We've got some other things happening later on with the questions, and we'll go into it in some detail. But it is very, I'll call it very similar to any well-built conventional house. And I say that with a nod to our daughter's house in South Minneapolis. It's built in 1928. The one that she had before that was 1924. My grandfather's house in Hibbing, Minnesota, up there not too long ago, and I drove by it, and that was built in 1928. It needs some maintenance, some painting, but the house is there, workable, livable. So really, in the cold climate zone, yes, the dome, our dome system is going to exceed from the standpoint of energy efficiency, longevity. All of our domes here, the 7 of the 8 domes, the 8th dome is really a prototype. Our mini dome is a prototype. But the 7 other domes, well, let's discount the 2 shop domes. Now we're down to 5. The 5 domes that we have all have treated wood foundation systems. They're just fine. The office dome that you see in the photo with the neon sign, that was built in 92. And that has a 9-foot, actually 9.5-foot high ceiling in the lower level. And in back of this picture is a drop off to about 30 foot down for a creek. The one on the right, which is what you're looking at straightforward here now in the middle, that's the original dome built in 1975. Recent pictures showing some of the snow. We have a lot more snow on it than we have in the photo. It works well. There's, you're talking really cold climate zone. Here's the this old dome, and the shingles underneath. We often show a fall photo with the shingles that are 39 years old. They're just fine. I look at them and I say it's at least another probably 10 years on those shingles. The kind of shingles that we're using now are Malarkey Legacy. They have a 50-year, that's a 50 warranty. So there's a lot of things that we do that are going to make our structures last for a long time. Wow, thank you. There it is. That was taken last fall. So this is 39-year-old shingles. And we live in a forest. Yes, the north side does have a little bit of moss on it, but that adds a little texture. That's about it. So I think there really isn't a question that the dome isn't going to last. It's just how long? 100 years, 150 years? There's a dome right now on the Greenland ice cap. They've abandoned the project many years ago, and they were supposed to remove the dome, and they decided not to remove the dome. So somewhere maybe 100 years from now, somebody's going to be investigating the summit of the Greenland ice cap, and their finders will go off and they'll go, there's some metal down below. Yes, it's our hub system in that dome. And it'll probably still be there for until somebody digs it up and transports and then takes the bolts out and disassembles it, then pulls it away and builds a house or sends it off to Mars or something. I don't know.
Huh.
Okay.
Nice. So
that's we're going back and forth here. So I'm going to grab my glasses back on here.
okay, I'll let you grab
This next question here is from John in Big Bear Lake, California. He's probably dealing with snow as much as we are right now. I don't know if John is on here. I don't have my gallery view up here to see if John is here. But the question he's got is, I've heard that skylights from the now defunct American Ingenuity domes in Florida could have issues with condensation and leaks, allowing water into the dome. Can you explain the likely reasons for those problems?
Yeah, that's interesting because Dennis and I were talking about that, and we don't know for sure if American Ingenuity built, their own custom triangle skylights for the dome. As from my understanding, they usually built a dormer system onto the dome and used conventional windows and kind of stayed away from skylights as they were kind of have an exterior concrete material. So I guess I don't really, know if they were using if this is regarding like a standard Velux type skylight that you could go buy at Home Depot, or if it was their own custom one, or if somebody just found a triangle skylight that they retrofitted onto the dome. But I would imagine the main reason for the leaks may have been due to the exterior. They didn't really have like a cladding, but rather they just used a concrete. You could put elastomeric coatings over that. So it'd be somehow sealing the window to that. When we sell a dome with elastomeric coating, which would be a smooth surface, non-shingled, we have a special frame that we built specifically for that type of application. So if you were just to try to put any skylight on that, is probably going to lead to issues, because most skylights are designed with a flashing system that diverts water from the shingles to the flashing, back off the flashing onto the shingles. That's usually how like a shingled roof works. It's just all about diverting water to the next surface until it gets completely off the roof. But like American Ingenuity is just more like a monolithic surface. So wherever the skylight attaches to the structure, there's going to have to be some kind of water sealing there. And without seeing the skylight or knowing exactly what detail this is, how they use that, or this particular person used the skylight, I don't know for sure, but whatever the sealing would have been, it probably was some kind of a caulking or something that wouldn't last real long, and that might be the problem. So like in our normal skylights, we do make the special ones for elastomeric roofing, but normally we have a big flashing system that we have about a 5-inch piece of flashing that gets integrated in with the shingles to prevent any kind of problems with leakage. As far as condensation, that can be a problem with any manufacturer's windows or skylights, just depending on the humidity levels in the house, the temperature differential from the outside. So that could be a problem with anything, but it wouldn't be necessarily like a above average issue, I guess, with our skylights versus probably anybody else's skylights. So actually had a second part to that question I'll read for you, Dennis. Assuming they could be due to a design manufacturing flaw, please tell us how your skylights address and eliminate these issues. I guess I might have answered that for you a little bit there, Dennis. Do you have that sample? Yeah, okay, good.
We've got our cutaway section of a triangle skylight. So this is one tip of one of our double pane custom skylights that we do. It's extremely well thought out from the standpoint it's been changed over the years. Basically, you have 2 panes of glass with a 3/4 inch airspace. There's a 2x4 frame. There's an aluminum top cap we call right here. This is a special extrusion of ours. There's stainless steel screws, and below this, there's a washer with an EDPM gasket. So right below that washer is the EDPM gasket. And the flashing leg that Derek was talking about right here sticks out 5.5 inches. Depending on how this dome is, how the triangle skylight is mounted, I'm going to leave this that close. We first put on a layer of ice and water shield, and it's HT, high temperature ice and water shield. When we do this as a point up triangle, once the window, and I'll turn this around and show you what we do, but once the window is mounted, we add another piece of ice and water shield right here. I'll just put this down a little bit. And this seals to this one instantly. And it seals to the flashing. So you can't have any rain getting in back of this flashing right here because it's sealed. And the shingles come all the way down to 1 inch from this curb right here. So that's where we get the second, that's really a third seal. The first seal is an air seal. And the air seal is right here. Get this set up right. Right in here is an air seal right there between the 2x4 and this ice and water shield. And it's the foam tape right in here. So that's an air seal. Mounting it, we give you these SPAC screws, and every 7 inches, you come away from this about 2 inches on the corner. And then at least every 7 inches or less, you put in this, and it goes into the 2x4 frame of our skylight. And this seals right along here. You don't have any air leakage at all in this part. And we've done 2 blower door tests on our house here and proved that our windows are going to be zero air leakage, basically, if it's done right. And that's the key, if it's done right. Follow our instructions. But you're going to have something that this seal right here, given, I don't know, the skylights on the original house that was built in 75, we put this kind of skylight on in 1983. And I'll get my face in here a little bit. So those skylights, and you go back to the picture, Tanner, from showing the Forest Dome. Those skylights, there's a Velux skylight in that picture too, but there's a couple of triangle skylights. They've been there for 39 years, and we have not replaced the tape sealant. You'll see the hexagon window on the left, that's in the bathroom. That's a 4-pane skylight. The skylights on the right, those trapezoid skylights, are there because there's a wall intersecting it. Those are triple pane skylights. We have not replaced the tape sealant on those skylights in the 39 years, and they do not leak. The shingling is done correctly around them. You can see the flashing on the bottom of the skylights covers the shingles below the skylight. Above, that flashing is underneath the shingles. And you see the overlap that we have on the triangles on the roof when we shingled it. That's how we do our roofs. That's how we've been doing it for 40 some years. We learned our lessons back in the 70s, improved things in the 80s, and that's it. We've been doing this since the mid 80s. We found this system and we maintain that's the way that you do the shingling on the dome. And and integrate the skylights. So, all right.
Okay. All right. And there's kind of a little bit more to this question there, Dennis. Let me kind of bounce around because there's another guy who had a question, Jafari, and from Missouri, and he said he's the owner of a 1977 dome. We were thinking of doing some updates and have some general questions about window replacement. So, and I'm going to read the other part of this one. Finally, can your skylights be located? This is back from John again. Finally, can your skylights be located in any triangle on the dome? And what, if any, issues may arise from any given location? I guess I'm putting those together, combining those two, Dennis, because our skylights do work for other dome manufacturers as well as our own. But there are some limitations on some other dome manufacturers, such as removal of struts, a couple other things. Sometimes they're a panelized system, they have framing. So there's some considerations there, but you know, with our skylights, Dennis, really probably the only consideration in the picture that Tanner has up, you can kind of see where it could be a little bit of a problem on the far right over there with the 2 trapezoid skylights, is oftentimes, and this is true with any skylight made from anybody, when you have a roof that creates a valley, which is where multiple roofs come together, you usually get a lot of water that accumulates in there and it really rushes out. And so sometimes, despite Dennis's skylight here making it all these years with no problem, but sometimes that's not a very good location for a skylight to have all that water pouring onto it. So that's part of the design where Dennis will kind of evaluate what your views are, and it can be done. It's just a little bit more of a risky area. But other than that, in our domes, you can put a triangle or a skylight in any triangle that's available. So you're not really restricted on where you have a skylight. Wherever your view is, you can have a skylight. So is there anything you wanted to add to that, Dennis?
Well, Tanner, do you want to switch to a screenshot of where my camera is facing? This is our grouping here of, there's 9 triangle skylights here. They go up quite tall. They're about 20 feet high. So this grouping that you see right here, these are triple pane skylights. We actually have a double pane. I think it's one back over here because we had that in stock. But we have a hard time right now with triple pane. The price is a little higher than we'd like to see it. But if you're in a really cold climate zone, we're going to suggest triple pane. We do have a customer farther south that decided he's going to want triple pane skylights. There are some skylights in our shop right now. The glass is made by Oldcastle Glass, and it's made to our specs. This is a really sophisticated skylight, more than I've got here. What we're into is this. First of all, there's supply chain issues. So we went with, what does the glass company stock? Well, they stock Solar Band 60, Solar Band 70, which are vitro manufacturer skylights. That's the low E coating. They're very, very good for reducing the solar heat gain through the skylights. They're also very good, and we use a 3/4 inch airspace to get the U value, which is the insulation value, down low. The normal thing that we do is 0.25. The code right now says 0.3. The lower the better on the U value. But if you want 0.21, we can do it. If you want 0.19, 0.19, we can do that. We can provide that. The glass is made for the individual domes. We're doing some right now where we're using Solar Band 60 low E coating on a solar bronze light. And then the interior pane is clear, and we're using Solar Band 70. And the numbers, the UV on this, the ultraviolet light coming through is 1%. We have a customer specifically requesting. He said, no matter what you do, I need this 1%. So we can do solar bronze for tinting, which cuts the glare out of the skylights, along with, yes, it's going to reduce some of the heat gain. So in Joshua Tree, well, there you go. We want that solar bronze and maybe a slightly darker tint, and we can do that also. So this is not something we just stock and pull out a piece of glass and here it is. It's ordered. Our lead time right now on glass is 4 to 5 weeks, and then we stick it into production. So this is designed to go with your kit, with the truck going out of here. We do have split shipments that we do. We did one here recently, and the other half of it's coming up actually next week. We'll be shipping out 18 triangle skylights with a 60-foot diameter dome interior panel. 190 interior panels. So we do split shipments if you want your dome earlier and then take your skylights and interior panels and insulation later, but you're paying that cost for shipping. So I think that answers the questions. Pretty good on that.
I think you got it. Yeah, that covered pretty good. So I think Lawrence is up next.
Yeah, Lawrence from Connecticut has a question. Does an attic cupola weaken the structure? And then he really wants to know about chimney placement. Do you put that on the exterior wall or off center? What's the best placement? And based on size, what are you dealing with?
Yeah, I mean, I guess, I'll let you talk about the chimney, Dennis, but I'll address the first part of that question. And I would say that an attic cupola does not, well, it really depends on the dome manufacturer. So in certain cases, some dome manufacturers need to leave the struts in place because the removal of the struts would weaken their structure. And so they can still put a cupola on there, but the struts need to stay in the cupola, which is less than ideal. Especially like in my case, I don't know if you can kind of shoot it back my way, maybe Tanner, but we got a cupola here and you can maybe see that it's got a floor in it. And so in this case, there's no struts up above. So when you walk up into that cupola, you're able to see 360. You can have a chair up there. You can have a little yoga mat. You can do whatever you want. So you have those options available to you. But we also have a dome that's, the system of the dome is very strong, and we're able to remove those struts without compromising the strength of the dome itself. So in our particular dome system, removing or adding a cupola does not weaken the structure at all. And a lot of our domes have cupolas on them. This one has a floor. The dome Dennis is in is just open cupola for light and ventilation, which you can do. You do not need to have a cupola. Here's 3 cupolas and 3 domes. So you don't have to have a cupola. There's no upside or downside. It's more, do you want that light and ventilation? Do you want that little kind of special room that's a unique room on a dome that you could have? But you don't need it for the performance of the dome, as far as for dome shell ventilation, the ventilation of the structure, not really the interior air. So it's not necessary. And some dome systems would require you to leave the 5 struts in place. But in our dome system is completely optional. There's no upside or downside to it other than aesthetics and if you want it or not. And it does not compromise the strength of it. So hopefully I kind of answered that for you, Lawrence. Yeah, we got a lot of good photos of the cupolas. It's kind of a fun feature. I think people that have, when they come here to tour the domes and they've never been in them, they really seem to get excited about the cupola, because it's just kind of a very unique and interesting space that it's not just unique to domes, but they're very cool in a dome. So
I'm going to just add something to that, Derek.
sure.
We do have specialized venting for the dome. The one that you see in front of you at the base of the triangles that are shingled, there's a little flip out, little base vent drip edge that we have on this dome. And there are air intakes at that point. And we drill 1.5-inch diameter holes in the bottom along the edge of the triangle, coming up about inch or 1.5 inches from the base of that triangle. That allows air from the outside to go inside. And then there is a barrier there, which is both your insulation, and on the first row, you're doing it like down here where this dome is, there's a scrim on the inside, but it works its way to the top of the dome. We have specialized ways that we do this for different climate zones. And then in a ventilated 1.5 to 2-inch airspace between that and the insulation. It works its way to the top of the dome, not with mechanical parts, but just by natural air movement. And the sun comes out and that air flow is going through the top. There's wintertime when we're up on the top of the dome and you can feel the warm air coming out. There's a ventilation system that we have where that wall of the cupola with the windows in it that you see up there meets the dome shell. Special flashing. We use a lot of ice and water shield in that situation. This dome is in North Carolina on the beach. And this works extremely well from natural ventilation. We can open when the wind is always coming off the ocean in the afternoon. And well, almost always. And you open the leeward side and you'll suck air out of the dome. So when I've been up there in a storm, watching the wind go up the dome, going up vertically, and it gets to where the cupola is and it turns horizontal and wraps around the dome and goes back out the other side horizontally. If you open up the seaside and the leeward side, the intercoastal waterway side, your hair will move from the air blowing through that window to ventilate the dome. And it's cleaning the inside air out. Open up some lower windows to let some air come in and it'll go right to the top of the dome and be sucked out. If you don't open the leeward side, just open the seaside. So we use that in the placement of windows that open a lot in the design of it to allow this natural air ventilation. We don't want you running the air conditioning all the time. We don't want you to run the heating all the time. There's many, many parts of the seasons in all climate zones that you really need natural air because it's just going to be cheaper. You don't have to run mechanical equipment. And you have to deal with humidity in different areas or dryness in some areas, but that's where you live. So there's a lot of things that go into this venting of the dome or not venting of the dome, a hot roof and no hot roof. So that's probably a little more detail than anybody wanted on that.
No worries, no worries. We got a fun question, actually. I think it's pretty cool coming up next, but real fast, we had a question in the chat from Jonathan Martinez, and he was talking about Title 24 in California and the complexity of, well, not really the complexity of the dome, but how it integrates with the values they allow you to input, such as 16 or 24 inch on center. Asking if there's a specific person. So I actually am working with another customer. Jonathan's one of our customers, but I got another customer in California who is working with somebody on Title 24 I might be able to recommend. But in this case, I told Jonathan that tonight still I try to get those values for him because we can calculate fairly easily here and give you the numbers that they need for those Title 24. So one of the confusions, and I guess the reason I wanted to talk about this real fast now before we get into the next question is they simply say 16 or 24 inches on center is what he states in his question. And that would be for normal framing, but in our triangle, in the triangles of our dome, I guess, it's completely open. There's no framing inside there. So it's just simply nice big triangles of insulation. And so when you are doing the Title 24, it's much more, the numbers are much more efficient than a conventional house that would have framing at 16 or 24 inches on center. So it saves you a lot of that thermal bridging, they call that. So anyway, I thought I'd just touch on that quickly before I get into this next one, because it's kind of a fun question. And I'll still get those to you tonight, Jonathan. But this question is from Bill from Hartford. And so Bill says, we still live in the Nelson Dome, a 44-foot diameter dome we purchased from T-Bop, which was the Big Outdoors people, built in 1975. We have one circular double pane window that has developed dirt internally between the two panes and need to clean it. There is a robust gasket on the outside that needs to be removed to get to the space to clean it. I need a person or company that will do that. Since I am now 78 and it is not as nimble as when I crawled around building this place. So this gentleman, Bill, is a builder, owner of this dome from 1975, and the circular double pane window, which they quit that building technique a long time ago. The fact that it's almost 50 years old blew my mind initially. And then all of a sudden, Dennis produces all these articles of this guy. So Dennis, I'll let you take over because you probably have known this guy for almost 50 years, or at least,
Is Bill here? Is Bill here, tonight? I don't know that he is.
I hope so. Yeah. If you're here, Bill, please jump in. I'd love to hear a little bit about this story.
Probably surprised that I can drag a picture up from 1977. Here's your dome, you and your wife with the dome. If he's not here, it'll surprise him when he sees the replay. Go back to that picture there, Tanner. Stay on that one. This is a system that was used back in the 70s. Elastomeric coatings and a rubberized gasket around the triangle rounded corner skylights. Kind of a space-agey look at the time. People liked it. It worked. The gasket is made by Stanlock, Stanlock, Stanlock company. It's still around. It's an H gasket. So one side of the H channel the glass goes into. The other side of the H, the plywood, or in this case, OSB board that we were using, goes into that. And then there's a special zipper lock around the outside that when you put this triangular piece of zipper into it with a special tool, which we still have, it puts the pressure on the glass and the pressure on the wood and seals that window. Now, what we learned over the years was the rounded corner, we were using the tightest radius that we could get And over the years, depending on the climate zone, they relaxed in that corner. So then you go to a wet seal and use silicone between the glass and the gasket and the elastomeric coating. So there were ways that we did this. Go to the other picture that you were on there, Tanner, with Bill and his wife. If you can. Maybe Tanner skipped out. There you go. All right. It's also cedar shake. And yeah, we sealed between those gaskets and the cedar shakes. It's a hard one to deal with. You see a lot of dormers and a lot of conventional windows. Go to that next picture relating to the cedar shakes that I cut out. I think this is the circular window right in the middle and the top that Bill is talking about. Bill, if you're on and you want to join in here, certainly do that. But this is the neat thing about it. So here's a customer, and the question comes up later on longevity of domes. So we had it before. We're dealing with somebody that's living in a dome for the last 50 years or more. We're dealing with our dome over here. It was built also in 75. We started some domes back in the early 70s. I got into domes really back in the late 60s, doing stuff with two different companies, Wendell from Dome East out of Long Island, and then another company with Pete Tobias, Domes and Homes in New Jersey. So that was in the late 60s, going into the 70s. Then we created our own systems. So sorry to say, I mean, that's the longevity of our domes, but what's your house? I mean, like I said before, you have some houses that have been around for 100 years. The dome that we have that's built in 1975, other than the remodeling we did, which was changing the inside and stuff, it's fine. The pieces aren't rotting away. So, yeah, I should mention that I was T-Bop. T-Bop is the big outdoors people. T-B-O-P. So, of course, as hippies, we go, yeah, T-Bop. And that's what we called ourselves from the inset. The name was just dreamed up one time. We had to get a name, and so that's what we came up with.
Nice.
So sorry if Bill's not here. We opened up.
He put a note in the chat that he's here. He just doesn't have a mic.
Oh, good.
So,
I can talk to you and you can't talk back. Yeah.
Yeah. But he has to see the pictures. If you want, we'll have to mail you some copies or something.
Yeah, the edges of the newspaper are a little eaten away by the mice. They were stored not in a sealed container. I happened to dig these out. Now, this is strange because I happened to dig out this picture, this newspaper from Milwaukee last week. This question didn't come in until the last couple of days. I didn't see this question. I saw this question last night. So it's this phenomenon of the dome where things just happen that way. I'm not going to be out to fix your dome because I'm older than you are. But Derek's younger. You know, maybe that's the case. We need these younger guys to come out and fix these domes. Tesla won't let you get up on the roof anymore. So I can do it, but he doesn't want me to.
Yeah, that would be cool. Maybe we can somehow do a video tour of it, and then that can take care of it. Take care of the cost. So
well, we'll move on to that, and I'm sure Bill and I can talk tomorrow on the phone here or do a Zoom chat. So
yeah, that's pretty fun.
All right. Well, we got a question coming up here from Lori from Wisconsin, and she's wondering if we could make the virtual dome school YouTube videos available for free to people who have attended in-person dome schools. It would be a good review that we learned in person, since some time has passed and we've forgotten a lot of the things that you talked about in detail. And maybe when a kit is ordered, you could make the video available. Well,
Yeah, I think the quick answer to that is absolutely. We did the virtual dome school initially as a result of the whole COVID situation, trying to still create something that would help people build their domes. And yeah, absolutely. I mean, if you came as a dome student or you buy a dome kit or you're somehow involved that way, absolutely it will be made available to you. We want to make sure you have as much information as possible. In fact, that's one thing Dennis offers is, we'll charge for some of this educational material up front because it does cost us some money for the dome manual or the virtual school. But if you buy a dome from us or anything, all of this stuff gets credited towards the dome. So we're kind of look at it like we like to be able to make this available. So yeah, if you went to dome school physically, then you might as well just consider the virtual dome school as part of the admission, I guess you could call it. So absolutely. And we have done that a couple of times, and we're kind of glad you said this because Dennis said starting today, this is just going to be the standard practice. So anybody that's gone to our dome school and has not gotten a virtual dome school copy or who is buying a dome, we want to make sure they have this available to them. So it is almost almost 11 hours or almost 12 hours long. There's a lot of information there, and in the very beginning of it, it kind of says if you go to hour 6 and 15 minutes or whatever it may be, here's where we start roofing, or here's where we start building the dome structure. So we tried to kind of make it real easy just to jump in when you are at that point. If tomorrow you're going to put up the riser walls, you can kind of see where that is and get a quick little video of what we're doing. So if you ever want to build a natural spaces dome, I think the video is definitely going to be helpful to you. And of course, if you're buying a kit or you're going to school, it's available at no cost. So yeah, thanks for bringing that up, Lori. It's a great idea, and we've been doing it, but we just it wasn't until you inspired us to make it an official policy here to just make sure we get that to everybody. So yeah, okay. Let's see. So then we got. Lorraine from Texas had a real quick question. How are domes fire rated? So you may want to grab that one, Dennis. I mean, it's really, like you kind of mentioned, it's more material based than structure based, but yeah.
So Tanner, you want to grab the San Diego Dome, Alpine, California, near San Diego. What we did in a dome down there, that actually the owner had two domes. They both burned down in one of the fires northwest of San Diego. And he came to us and said, okay, I need a dome, but I need a fireproof dome. So Bill came to us and said, what can we do? How can we do this? So these are our domes. And they have 3/4 inch plywood on the outside of the dome. But on top of that, they have 1/2 inch cement board. And cement board comes in 3x5, it's so heavy, it comes in 3 foot by 5 foot pieces. So they screwed these to the 3/4 plywood and created special pieces to fit in between and to make triangles. You could use all the scrap. There was virtually no scrap in the product because you could fit it into different places. So they coated all of the joints with a similar compound. And then the whole thing was covered with, I want to use the name Supercrete, but I think they used another one, similar product, which was different than Supercrete, but same type of product. So that provides a seal coating on the outside of the cement board and provides a leak-proof exterior. You'll notice that we have on the far left and over the door on the right is the soffit of that roof, and the door in the middle too, where the patio door is. The soffit is slanted from the top of the door to the eave, to the fascia board, I should say. And that's to stop the smoke. First of all, it's not vented. There's no ventilation because you're going to have burning embers coming into your structure as far as vented to the space of the structure. So those are designed to allow the smoke to go rolling up and then right back out again. They don't linger in a 90-degree corner. So that's all part of this. This being California, they are required to have so many gallons of water storage. The swimming pool is considered part of that. But I know in the Malibu Dome, they required 15,000 gallons of water in a storage tank. They also required a driveway that a fire truck could get up into it and turn around. So that was part of it. You had to have a big enough space for that certain length fire truck to do it. So there's 4 domes in the complex, and the pool is in the front of this picture. This is during construction. You'll see the vegetation. There's 3 different zones of vegetation in front of that dome going down the hillside. First of all, to stop erosion, but also they are specialized plants designed for not drying out in the desert, in that dry climate zone. You can see a storage tank in the back next to that storage trailer in the back of his house. That's required by code, along with that, the water in the pool. So from a fire standpoint, we've got domes up in California, all over the place. Did all of them do this? No, they didn't. But we were aware of things happening, and especially with these 2 domes being burned down. There you see a construction shot, and it shows the cement board with coatings in between, the cement coating in between the joint lines. And then the whole thing was sprayed with this supercrete material on the outside.
And you may have mentioned this, Dennis, but this wouldn't necessarily be required to have a Class A fire rating. This is kind of a good extreme example of a situation where, I mean, I was jokingly saying you could take a flamethrower to this house and probably not be able to start it on fire. But even regular asphalt shingles would be sufficient for most situations as far as fire.
They want a Class A fire rating on the roof in California and in most places. Malarkey Legacy shingles are Class A rated, which is the highest class you can get. They're also Zone 4 hail rating on them. So there's a lot to say with the final roofing product that you put on your dome. But the house itself, they don't have fire ratings yet in California, I'll say it that way, and especially in other parts of the country. There's no 1-hour fire rating on the walls. There's nothing like that. It's the commercial structures, institutional structures that have that. However, on the inside, the material that we use, which is the spruce 1x8 tongue and groove boards, and you might have an interior shot of this dome, Tanner, I'm not sure, but that's our standard material. What you see in back of me, what you see around me in this dome, it's a Class B, which is the best you're going to find in wood. It's a Class B rating. And Derek was mentioning that he had looked up this rating sheet that I had on it, and there are several species of wood which have a Class C, which is not very good. And it's a flame spread rating that you get. And I believe off the top of my head, I'm going to say it's got a 25 flame spread rating. If I'm wrong, I'm wrong, but it's in the best class of wood that you're going to find. I'll put it that way. For smoke developing and flame spread. So
Right.
I think that's covered. I think hopefully Lorraine has an answer on that.
Yeah, she did have kind of a follow-up in the chat, just wondering how long would that fireproof cement dome roof last and what sort of maintenance would be required. And I guess in that particular application, a lot of it probably depends on your climate. Like that'd be a tough roof in a cold climate where you have a lot of ice and stuff.
Well, no, this is the coating on the outside. The supercrete coating is
Mhm.
this impervious coating. And it's designed for this application over cement board. So the fire rating, I've got a friend of mine, an engineer who has done that for a living. And I should really have him tell me what tests have been done using a 1/2 inch cement board over the 3/4 inch plywood. I'm gonna throw this out that it probably has a 1 hour rating or more.
I mean, I
So-
think what she means is how long does it last in years as far as,
How long as it lasts in years, your coating that's been sprayed over it. I haven't talked to the owner, Bill, in a couple of years. It was built in early 2000s or late 1990s. And I don't think hasn't resprayed anything over it, but that would be the application. You'd wash this off, clean the surface off, and from the dirt and the dust, and then you'd spray another coating over it. It's the same thing that the elastomeric coatings that we do. My brother's dome up in northern Minnesota. Every 5 years, he would wash it with a light solution of muriatic acid that would clean off all the gunk from all the trees. The poplar trees up north are really bad, throwing junk on the trees, and then you get everything else clinging to it, the dirt and the dust. So he cleaned it off and sprayed another color coat over the top of the elastomeric. And that's what he did. And it was every 5 to 7 years on that elastomeric coating in northern Minnesota. So depends on your climate zone. We look for the product that's going to work the best in your climate zone. Let's see, Lorraine is talking about Texas, so you're in the hot, humid climate zone. If you're in Western Texas, it's dry. If you're in Eastern Texas, it's the moist zone. So we look at those systems that are out there and study their technical data to make sure that what we're saying is correct, and talk to the manufacturers of the material. Thank you, Tanner, for the map. You'll see the black line running through the middle of Texas, through the Oklahoma Panhandle and up to between the Dakotas and Montana and Wyoming. The western part is dry. The eastern part is moist. Now, with climate change, that line has moved to the east 150 miles. That's what they found. So this is an old map. The new map shows that line further to the east. It's drying out. The west is drying out. Or I should say the west side of the moist zone is drying out. So we're aware of all this. We're what do you want to say? We're staunch environmentalists. We look at it, we understand it. We want to make your house last that couple 100 years. Yes, there's maintenance. There's maintenance on any house. Look at all these houses from the 1900s that are still here. They've had new roofs. They've had maybe new stucco coatings. In Minnesota, we use stucco a lot. Was done right there with lath and plaster on the inside. So you look at those things. So let's move on. Should we? The next question. Get my bearings here on this. So the question now is from Dan in New York State. And this question is, we are thinking we want a mid profile with the riser wall dome based on the aesthetic and the internal space. Can you discuss the advantages or disadvantages of the low and the high profile domes along with the mid profile dome?
Yeah, so I don't know if you guys can hear
Discussion.
that. What's that?
I said this will be a quick discussion on it because
Oh,
we do this
Yeah.
in math class and it's like a half an hour. So we're only going to spend a little bit of time. And this is the
right.
simplified
So,
version.
so yeah, this is, like Dennis said, this is real quick. So if you imagine a sphere and you were to cut the sphere in half, that'd be the middle of the sphere or mid profile when you're talking the profiles of the domes. So since domes are subdivided from a triangular shape, you get rows of triangles. And so in certain frequencies, and I don't want to complicate this like Dennis said, because this could go on to a full discussion on its own, but you'll have a row of triangles that may come all the way to the middle of the dome. So that'd be a mid-profile dome. Or you can eliminate one row of triangles and it, whoops, this is actually backwards here. You can eliminate one row of triangles and make it a low profile dome. And usually that's available both in the 3 and 4 frequencies. And in our case, we have a 5 frequency that you can have a low profile. The 5 frequency technically cannot have a mid profile as any odd frequency. And the frequency is just a subdivision of the original shape, which is an icosahedron. But again, not to get into too much of the math, but essentially, if you go with a mid profile, you get a little more upper floor space. That's one advantage to it. So if you wanted to have a lot of space on your second floor, maybe 2 or 3 bedrooms up there, you might benefit from a mid profile. A low profile, it has less space upstairs, but if you weren't going to use a lot of that, it does save a little bit on the cost because there's fewer components because you eliminate a whole row of triangles. So it really depends on what the owner needs in the home as far as more space upstairs or not. And a 3 frequency, because it's an odd frequency, you don't actually have a mid profile. So you either have a low or a high profile. So again, not to complicate it, but any even frequency, you can have a mid profile. Any odd frequency, you can't. And with Dennis and his mid 4 frequency domes, which is popular size, he does offer a low profile version of it, even though it can have a mid. So I don't know if that if that helps. I'm trying not to complicate it too much, but so essentially this just gives you more room on the height is really what you're accomplishing. You know, the floor to your ceiling height is different in each one of these profiles, and it just gives you more usable space on that second floor. So is there anything else you want to add in there, Dennis? You might be, I think you're muted, Dennis, maybe.
That's better.
There you go.
So just be very quickly, the domes that we have that are 20 to 29 foot diameter are 2 frequency domes, and they can do a mid profile. The other domes from 30 foot to 40 foot can only be a high profile or a low profile. They're 3 frequency. You can't do a mid profile because you're cutting through the middle of all these triangles and struts. But then the 41 foot or say 42 foot diameter domes through 51 foot diameter domes, we're into a 4 frequency dome, and there are the mid profile and then a low profile. So you tell us what you want on the main floor. You tell us how much second floor you've got, and we'll work with you on the size of the dome and the height of the dome. And there's some cost involved too. So that's all part of it.
Right. Okay. Cool. I'll set you up for this next one, then I'll move this back. So and I think that was from Dan, which we spoke a little bit on the phone, Dan. So yeah, I can always get into more of it as far as when it comes to the design of your home too. That might be helpful. So this next one is from Larry, and he is from Colorado. And his question was, any experience or suggestions on window coverings? We are an NSD owner and have TV glare issues. NSD just meaning Natural Spaces Domes owner. So he's got one of our domes and he's wondering how to handle some glare coming in through one of his, I assume a triangle skylight. So.
Well, it's probably, I can oversimplify it by saying just move the TV, but reality is any house, if you place the TV in the wrong spot, you're going to get a glare off of whatever is in back of you or at an angle from your view angle. And it's a hard one from the standpoint that you might have, and Larry does have a lot of glass in his dome. He's in Colorado. So he's going to have some bright light coming in. So it's all of these things that factor into it. And it's just a question we just wanted to talk about just a little bit of here because I know when we were building the guest dome for my sister-in-law, we were going to place a triangle window over where the TV was going to sit in front of the riser wall. And she said, well, that's not any good. She said, because that's south facing. And you're going to tell me I'm supposed to watch my daytime soap operas with the sun glaring through this triangle window. She says, it's going to hurt my eyes. So yeah, I didn't think about it. So we didn't put a triangle window over the TV set. It's hard to tell you where you're going to have the reflection happening. You can cut down some of the glare. Tanner, if you want to go back to some triangle window photos, what we're talking about in the chart that we have here is the tinting that could be done, and we can cut the glare down from the sun coming through your windows. That can be done going to solar gray, solar bronze, or if you really want to see the view out, but look through a gray or bronze so-called mirror tint window, that is available also, called solar cool. The problem is, whichever side the light is on, that's the reflecting surface. So at nighttime, if you have these windows and they were solar cool, they would reflect the sunlight, cut the glare and the heat down coming through the skylights. But at nighttime, the inside would be a mirror. You'd be seeing yourself just like you would in front of a mirror, and everybody else outside can look straight into your house. There's no reflection at all in the nighttime, unless the moon was out really bright, maybe. That might do something. But the glare inside the house that's reflecting from the TV, we have a situation at our cabin, and there's a situation where the lights in the back in the kitchen across the living room, dining room are reflecting into the TV set. So angle the TV set down. We just raised it up and we're going to angle it down. You play with this. So it's not peculiar to a dome, but maybe so from the standpoint of you got more windows in the dome, more skylights. All right.
Okay.
We can talk to Larry too about the other things and exactly what he means, and he can show us what he means.
Yeah, and there's different window covering options and stuff.
Yeah.
So, okay.
So, another question that's part of that is, can the skylights be anywhere in the dome? And the answer is yes. This dome you're looking at is in Sedona. It's got a fantastic view. There's 19 skylights looking at the view. So they can be anywhere. The question that Derek can answer is, does an attic cupola weaken the structure?
Yeah, I think you might be one page behind us.
I'm one page behind you. Now let's get.
We're on Larry from.
Right. Okay, there's this page, and then that goes to this page. Yeah. So the question is really from Larry in Ontario, Trent Lakes, Ontario, Canada. What is the largest four-season clear polycarbonate dome for the far north, and what is the cost?
So this isn't a polycarbonate. This is a glass, but of course it's clear if you're looking to see through it. And this is this solar dome, Dennis? You said in UK.
Solar dome out of the United Kingdom.
Yep. So that's this is probably, at least in the dome community, probably one of the more famous domes that somebody utilized for this kind of purpose, where they built their home inside of this other dome. And then they, so if this was what you were kind of envisioning, this is one option. Another option is that's made in the United States is growing spaces, which is right here. This is actually polycarbonate. It is considered clear polycarbonate, as in it does not have a tint, but it's opaque, you really don't see through it very well. It lets a lot of light in, a good amount of light transmittance, but it doesn't allow visually for you to see out of it. But this one is, we refer to them quite often for somebody that's looking for a similar application as this. They don't build homes or anything. These are all greenhouse domes, but they work great for that application. Dennis, you actually went up to that previous dome that was on here in Norway. Did you want to talk a little bit about that? I think you were actually in that dome, weren't you?
Yes, we were. Tessa and I were in, this is north of the Arctic Circle, just on an island that's just off of Boda, is what they say. It's Bodo, a town north of the Arctic Circle. And our client was Ole and Sandra, and this was her sister that built that dome. If you want to go back to that dome, Tanner, just for a moment. And they had built this dome a few years before, which gave Ole and Sandra the idea they wanted to build a dome, which they did one of ours, not all glass. They did have some large triangle skylights facing their view. You'll notice this is an oceanfront lot. That's what it is. The mountains are in the back. In the back of the camera view here, there's just gorgeous mountains. There it is. There's the lakeside or the oceanside view with this mountain in the back of it that they use for hiking and trails all around it. You can see the scale of this thing with the people in the prairie in the front. It's available to look at online. There's some new video that was just done recently in the last couple of years. I've forgotten Sandra's sister's name. I don't know if you remember it, Tessa. It doesn't matter. Go online and look up Norway Solar Dome. You'll find it on YouTube. More than one thing. And there is somebody that actually has a blog about alternative housing, and she's got a really good video interview that was done with Sandra's sister. So if that's what you're looking for, we don't do it. Sure, we could say, well, let's take our dome, put triangle skylights in every single panel. We could. The structure would stay up because it's all based on the structure of the struts supporting the dome. The same case is true here. Do they have snow load? Well, maybe has some snow, yes, north of the Arctic Circle, but you're sitting with an oceanfront lot and the ocean's 50 degrees or whatever it is. So you're not going to get, you don't have frozen ocean up there. So whatever it is, it's moderated. You'll see the solar panels, they work. There's a top deck on this dome. The house inside is 3 stories tall. And the upper level is a deck, a sun deck. The very top pentagon of the dome lifts up. So with a little chain and a wheel, you can crank the entire pentagon up for air ventilation. And they have some areas down below that open up to let the air in. They grow things in the middle of winter inside of the dome. They can go and pick fruit in the middle of winter. There's a season for all these things too, I should say that. So that's all part of it.
Right. Okay, good.
All right.
We're almost getting there. We got a couple more questions. The next question is from Paul in Australia. This is a pretty good sized question though. It's a two-parter.
So we're not going to read the whole thing.
Oh, okay.
This is what I started talking about before we started.
Oh yeah. This is I'll wait on that one. That's right. Yep. Okay. So
just to say, Paul is listening at the moment. We'll talk to you aside from the Zoom talk. He's talking about creating a 9-frequency geodesic dome geometry, which we don't do and haven't done. But we do have a connection hardware system that can be utilized for doing these specialized things that he's talking about. He wants to do hexagons and pentagons, so you don't see triangles or you see a few triangles. So all of this thing, you can take our connection hardware and play around with it. We've got somebody right now up in Duluth that's looking to build an elliptical dome vertically, not horizontally. And he's taken our connection hardware system, and he's going to make this thing work with some of our discussion that he has with us. So, like I said, it's a long, involved question, and it'd be very technical to get into this discussion tonight, so we're going to postpone that. But we do, Paul, if you're listening or you hear this, or we'll contact you tomorrow to tell you what our answers will be on your question, a long question. So the last question that we have coming up, it says, what is the best foundation to build on? Concrete or treated wood? And this is Tom from Hudson, Wisconsin talking. And he says the land is in zone 6 and 7, which is a climate zone in northwestern Wisconsin.
Yeah, really, I was talking a little bit to Dennis about this earlier, and it's really kind of, I don't know if one stands out above the other real strongly. They both are going to have their advantages and disadvantages. So for instance, in treated wood and where we are, like Dennis said, the building I'm actually in right now has a basement 9.5 feet deep. That is a treated wood basement. The dome next to us has a treated wood basement that kind of is a combination as it comes around over the edge, that part of it's out of the ground, part of it's in the ground. I don't know if you have an average depth on that one, Dennis, but that one is a treated wood basement. The dome following that one is a treated wood foundation crawl space. And the photo that Tanner had up there was Bear Creek, where Dennis currently is. And that's a treated wood shallow frost protected foundation system. So there's a lot of treated wood where we are currently, and they've all held up great. They all work great. So we can kind of talk to the longevity of them. Some benefits of it is they're flexible. They don't crack like concrete. They can be assembled in wintertime. So you don't have to really be dependent too much on the climate. They're usually a little more cost effective, easier to insulate, cheaper to insulate, a little more environmentally friendly to build and insulate versus concrete with foam like a ICF block or something. So those are some of the advantages. Advantages to ICFs are they're extremely robust. So depending on your environment and if you have certain openings in the dome that really need a good strong wall system underneath it, you can't get much stronger than ICFs. They got the foam built in for insulation as all part of it, which is very nice. So again, you have a lot of advantages to either system. Sometimes cost, when wood was real high a few years ago, or a year and a half ago or whatever, it's probably better to buy ICFs from a cost standpoint. Now that wood's come back down, wood would be a little bit more cost effective to build than ICF. So, it's really just, I don't know if one stands out over the other, clearly. I mean, there's just pros and cons depending on what you need and what you want, what you can afford. You probably got a lot to add to that, Dennis, because you probably designed over a couple hundred domes with permanent wood foundations. Have you really heard of any major drawbacks to those?
No,
I know it's a hard sell for me initially, so I'm sure a lot of people are like, a wood, but
it's the one area that we have the fewest callbacks when we do a wood foundation. It's somebody trying to remodel it where they don't understand that it's a structural component and they may need a header or different things that they do when they want to put a door into it and they want to create a walkout. There's a lot of different ways they can do that. But if you're not a structurally attuned remodeler on any foundation, you want to be aware of whether it's concrete, ICF, anything. You've got to be aware of what your structure is. So in designing it, it's what you want to do. Some people say, well, I don't want to use any foam from an environmental standpoint. So, okay, let's not use foam. There are other materials. There's mineral wool insulation that can be used under the slab for insulation instead of foam insulation. So we can work with you. Foam insulation these days, there's a new product called natural polymer that gets rid of all these chemicals, the harsh chemicals. And I believe just recently, because I went to their site, it's now owned by Owens Corning. At least that's where it appeared. So they might have bought out what could have been competition for them because they handle spray foam stuff and do foam products. But it's just a different kind of foam. Same R value, R7 per inch as an average, as an aged R factor. So there isn't, like Derek was saying, there isn't one product that's so, far above anything else. We've used, like I said, ICF block all the way up to the bottom of the dome. And the floor system is inside of that. This shows you where the concrete falls down into there. You need somebody that's done an ICF block basement before. You have to make sure the pumper truck comes and pours the concrete in, and you need to get the air pockets out of that, and you have to put rebar and sticks down into it to make sure that you're getting all the cracks and crevices filled. It's heavily reinforced depending on the height of the backfill. But so is the 9.5 wood foundation that I did underneath the office dome that Derek is in. We have a stairwell that's got shear panels on both sides of the stairwell with plywood. That's just to hold the walls back from the 9 feet of backfill on the high side. So it's all in the design. And we've got structural engineers that can tell us exactly what we need to do, and we use them. So in the engineering of all this, something else from the standpoint, just real quickly before we end, there are 2 other companies out there. Superior Walls is a company that builds pre-manufactured sections of concrete foam insulated, already insulated with it. They've done several of our domes. They continue to do that. They have no problems with the angled corners. It's like a wood foundation. It sits on rock foundation for drainage purposes. You pour the slab inside of it. And they again tie into the floor structure at the top of their wall. There's another company called Epitome. It's just like it's spelled. Epitome, all vowels in there. That one was done in a 29-foot dome over on the border of Minnesota, South Dakota, in that area. And they pre-made the panels and brought them out, and they went together perfectly. They're insulated, pre-insulated. They added more insulation because we always have a certain R factor level that we want to see. A company is called ARXX, ARCS, ICF blocks, have a wide variety of thicknesses of foam. So you can get 4 inches of foam on the outside and 2.5 or 3 inches of foam on the inside. Get a high R factor in that wall. If you go to a regular cheap one, you're only going to get 1.5 to 2 inches. Well, it's usually 2 inches to 2.5 inches on the edges, inside and outside. Simply add another 2-inch layer of high density foam board on the outside to get that insulation level that you need. So.
One thing I'll bring up while we're still on foundations, and we had one question in the chat, maybe we can try to get to quickly, sure. But one thing that attracted me to domes in the first place, of course, almost from more of an engineering thinking process, I guess, was the strength of the structure. And even when you look at a foundation and you imagine the earth pushing on your foundation instead of having a 40-foot straight wall, like maybe in a conventional house where it's pushing on that whole thing, you have these smaller sections that kind of distribute the weight around. And so even the foundation on the dome allows it to be very strong. You don't need a lot of bracing walls below or anything. So I just thought that was kind of cool. I'd mention it. But it was actually a second part of a question answered earlier. I got the Skylight part of the question they asked, but this is from Kamara, I'm going to butcher it, so I won't even say it, and Jafari. But a quick question. The entire interior of my dome is made of MDF particle board with all the shards, and I can't go through the day without thinking 2 thoughts. 1, what can I do to achieve a smooth finish? And two, why did they choose this material to begin with? And that's our last question, it looks like. So
Well, it's
I don't know if it's a quick question.
help the Stumpus boys, I guess, here. Yeah. We do sell 1x8 tongue and groove boards in triangular panels. We're doing one right now. In fact, we've completed it. We're about to ship it out for somebody who came to us with an octahedron dome, which we don't normally do. We did one or two actually many years ago, back in the 90s. And he just gave us the interior panel dimensions, and we created tongue and groove interior panels. And as you see in back of my dome up in here, but more in the back of Derek's dome with the lighting, there's a batten strip that covers the joint between the panels. There's a round hubcap that is the corner, and the batten strip slips behind that. And with that, you don't have any miter cuts. So if you wanted to cover up your interior, you could go with this 1x8 spruce tongue and groove one-piece triangle panel. We also have plywood. We use 3/4 inch plywood on the inside. Now we free span our triangle with 3/4 plywood. But in the case of what you're talking about, maybe what you're dealing with is putting a surface on that. And in the process of doing that, you get to pick what you want to do. Derek moved the rolling screen tuckboard away, and in back of him and back of that tree, there's a white panel, and that's 3/4 inch plywood. If you've already got a panel there and you got studs in your triangles, like they do in other domes, in not ours, we don't need it. You could use probably 1/2 inch plywood and put that over the material that you've got. If you're worried about any off-gassing or anything that panel might have inside as far as chemicals or glues, you can put on a seal coat, a non-toxic sealer coat over that, which is what I did in the old dome from the 1975 dome that we built that had OSB board. We sealed that panel and we put 1x8 tongue and groove spruce boards over that interior panel that we had on the dome. I won't go into it because we're out of time. Getting to be the magic hour that we want to end no more than 7:30. I know we continued on here with a few other questions.
Yeah.
But
there was two more that came up, and one of them is Jonathan. And Jonathan, if you want to call me tomorrow, I'll get into that conversation with you if that works. And then Van Wilson, same thing. That's a kind of a unique question, I think. But if you want to give us a call tomorrow, I'd be happy to answer that one for you. But yeah, great.
We try to use the Zoom call here to answer all these questions. So in one evening, we can talk to, 20, 30 people and get questions answered, instead of spending all this time during the day when we've been extremely busy. We're happy for all the customers that we've got. We've never been busier, basically, in doing the domes. We love it.
Thanks to all of you for coming tonight. I hope you enjoyed it, and reach out to Derek and for the ones that we couldn't quite cover. All right.
All right.
All right, guys. Have a good night, everybody.
Bye.
See you later.
See ya.